Hello, welcome to Finance 301, Module 2, Present Value and Bond Valuation, Case 2. Okay, hello. Now we're going to talk about future value. And so future value is the first question on this case, Case 2. And it's really all about the formula. So it's a question of, are you applying the formula correctly? Are you plugging the right numbers in when you read these questions to get the right answer using the formula? Now, some of you like to solve these problems in Excel, and I think that's great. I've shown you how to do the math manually for these, and if you can get the same result using Excel, that means you're on the right track. And you can use the Microsoft help page for Excel to give you the syntax of the function in Excel. There is a PV and an FV function in Excel that'll tell you the future or present value of something. It's FV to get the future value. So the formula, if you want to do this by hand, and I think I got to show you how to do it by hand so that you understand the calculation, right? So the formula to figure out the future value of something is P times 1 plus I to the nth power. So that little hat symbol there next to the N, that little, I think it's called negu in some countries, that for our purposes means you're taking something to the nth power. So sometimes you'll see it as like a superscript. You'll see it as, it's higher up than the other print, um, you know, x squared or whatever. This is, n means you take whatever comes before the end and before the hat symbol, and you multiply it by itself n number of times. So future value equals p plus 1 to the I. I'm sorry, future value equals p times 1 plus I to the nth power. So 1 plus I is taken to the nth power. The result is multiplied by P, and that's your future value. P is the principal, I is the interest rate, N is the number of periods. So $6,000 after being invested for 2 years in a savings account at a 2% interest rate is 6,000 times 1 plus I is 0.02 because 2% is 0.02 expressed as a decimal. 1 plus 0.02 is 1.02. Now we have 6,000 times 1.02 squared. So we have 2 years, something to the second power, right? 2 years, 2 equals n. Something to the nth power where n equals 2, or something to the second power, something squared. Let's take that number and multiply it by itself. So we're taking 1.02 times 1.02. 1.02 squared is 1.02 times 1.02. That equals 1.0404. So 1.02 times 1.02 is 1.0404. That times 6,000 is 624240. So we get the answer by taking 1 plus the interest rate times 1 plus the interest rate times 6,000 gets us to 6242. Now, the next one is for 8 years. So question B, we have 3,000, we're going to invest it for 8 years at a savings account that pays 3%. 3,000 times 1.03 to the 8th power is 3,800. So 1.03 times 1.03 times 1.03 times 1.03 8 times, right? 1.03 times itself 8 times gets you to a number that when multiplied by 3,000 equals 3,800. And now the next one, and you do that on a calculator, right? You should see a x to the y function on your scientific calculator, and you can just take 1.03 to the 8th power, multiply it by 3,000, get 3,800. You see the next example there was 7,500. That one's taken to the 11th power at a 5% interest rate. Now, what does it mean? So x, the star symbol means, asterisk symbol means multiplication. The hat symbol means exponentiation. And here we see 2 to the 3rd power is 2 times 2 times 2. 5 to the 4th power is 5 times 5 times 5 times 5. 5 to the 5th power would be 5 times 5 times 5 times 5 times 5. So you just multiply something by itself n number of times to take it to the nth power. And in this place, we're taking 1 plus the interest rate, taking that to the nth power, get the result, we multiply it by the principal amount to get the future value. All right, we've done future value. Now, how do we do present value? Present value is just the future value divided by 1 plus I to the nth. So present value is PV, I is the interest rate, N is the number of periods in that formula. Now, how do we figure the present value of 5,000 to be paid in a year with a 10% discount? An amount to be paid in 1 year is taken to the first power, which if you take, if x squared is x times x to the first power is just x, right? So in 1 year, we're just going to take 1 plus the interest rate, and that's going to be our result. So 5 divided by 1.1 is 4545. So that's how we come up with our PV with just a 1 year period. Now, if it was in 2 years, we would take 1.1 times 1.1. We would take 5,000 divided by the result, and we'd have a lower number as our value. 2,000 to be paid in 5 years at a 7% rate is 2,000 over 1.07 to the fifth power is 1426. So, and that's 1.07 times 1.07 times 1.07 times 1.07 times 1.07. That is 1.07 to the fifth power. You just multiply 1.07 times itself 5 times. You don't have to waste your time actually doing that because your calculator should have a function to do it, an x to the y or a y to the x function. It'll have a y and an x above it. Now, um, some of you are going to do this with Excel, and that's fine. You know, that's another way to do it without a lot of manual labor. So, how do I value a zero coupon bond? Because that's the next question on this Module 2 case. What's a zero coupon bond? All right, back in the old days, in the pre-Reagan years, Reagan passed a lot of tax laws that actually, you know, I don't want to say they increased taxes, but they got rid of a lot of tax loopholes. And one of the things he did was he got rid of zero coupon bonds. They still exist, but he imputes interest on them. So in the pre-Reagan years, you could save a lot of money on your taxes if you invested in a zero coupon bond. And what that was, the bond wouldn't pay any interest. See, if I'm a millionaire and I invest in a bunch of bonds, let's say I buy 100 million worth of bonds that pay 3%. I'm going to get 3 million a year in interest. I'm going to have to pay tax on that. I'm only going to wind up with $1.5 million after taxes. So they came up with a better idea. They said, instead of having bonds that pay any interest, we're going to have bonds that don't pay any interest. But, you know, you're going to invest 900,000 in the bonds today. They're going to sell at a big discount, right? If a bond doesn't pay any interest, nobody's going to pay much for it, right? So they issue the bonds with a face value of 100 million, and they sell them to you for 90 million. And then instead of holding onto the bonds for 3 years at 3% interest and getting 9 million or 10 million in interest over 3 years, you would hold onto the bonds, not get any interest payments for 3 years, and then you get 10 million at the end. They'd pay you 100 million at the end to cash in your bonds, even though they're only worth 90 million when you bought them. So they would sell the bonds at a big discount. And that's called a zero coupon bond. It's a bond that doesn't pay any interest, but the interest is basically built into it because you just pay less money for the bond and you get more at the end. So it's basically saying we're going to pay you your interest at the end, and we're not going to call it interest, we're just going to call it a redemption of the face value of the bond. So that's a zero coupon bond, and that they did that because there was no income tax then, because there was no interest being paid. The government only taxed interest. What Reagan did was he said if a bond sells at a discount, you have to amortize the discount over the holding period of the bond and treat it as interest. And that was called a original issue discount. That means if a bond is floated at auction for less than the face value, that discount has to be amortized over time. And so the OID, or the original issue discount rules, kind of got rid of the tax advantage of zero coupon bonds, but they still exist. So all this to say, a zero coupon bond that pays 3,007 years just as a bond that doesn't pay any interest, but it pays you 3,000 the face value in 7 years. So if you got a 3% discount rate, a required rate of return of 3%, like let's say that's inflation, for this investment to break even with inflation, you know, you need to pay no more than 27.45 for it, because 3,000 over 1.03 to the third power is 27.45. 1.03 to the third power is 1.092727. So, you know, that's what you do with a zero coupon bond. You basically um, treat it like a present value problem, right? You take the future value, that's the payment you're going to get at the end, divide it by the interest rate to the nth power, 1 plus the interest rate to the nth power, and that equals your present value of the bond. A bond that pays 1,000 for 4 years with 4 annual coupons of 30 each. Here, you have to take, the face value, discount it by 4 years, take the first interest payment, discount it by 3 years, the second one discount by 2, third discount by 1, and the fourth doesn't get any discount because you get it at the very end. The I'm sorry, the fourth payment does get discounted. So the way it's going to be is you're going to have 1,000 divided by 1.03 to the fourth power plus 30 divided by 1.03 to the fourth power plus 30 divided by 1.03 to the third plus 30 divided by 1.03 to the second plus 30 divided by 1.03. So you're gonna have 1,000 divided by 1.03 to the fourth plus 30 divided by 1.03 to the fourth plus 30 divided by 1.03 to the third, plus 30 divided by 1.03 to the second, plus 30 divided by 1.03. And so why do we do that? Because the first payment comes in a year, right? So that's got to be discounted by 1 year, and the last payment comes in 4 years, so that's got to be discounted by 4 years. There's no payment immediately, and so there's no $30 that doesn't get discounted. But what's going to happen is you're going to discount all the other, you're going to discount all the payments that you get to the present value, and you're going to sum that all up. And so it's a kind of a messy calculation, but that's how you get to the PV of the bond. And so what's the par value of a bond? All bonds have a face value of $1,000. So the par value is 1,000. That's the amount of money you get at the end when the bond comes due, when they pay you back. What is the coupon rate? That's the rate of interest divided by the par value. So if the bond pays 2% interest per year, it pays you $20 per year of interest. That divided by par is the coupon rate. So the coupon rate is the dollar amount of interest paid per year divided by the actual cash interest payment divided by so it's the actual cash interest payment divided by the par value. The actual cash interest payment is $30 cash per year. It's 30 divided by 1,000. That's 3%. So that's par value. Par value doesn't take into account any amortization of original issue discount or anything like that. It's just the cash payment divided by the face value, the par value. Okay, the relationship between bonds, interest rates, and inflation. Long-term treasury bonds are more sensitive to interest rates than short-term treasuries. So the more time that's on a bond, and this is true of treasuries, it's true of corporate bonds, the more interest rate sensitive they get. Because if interest rates go up, uh, that impacts a payment that you're going to get in 30 years by a lot more than it impacts a payment that you're going to get in 2 years. So because that change in interest rates is going to be compounded over time, right? So 1% per year for 30 years is more than 1% per year for 3. And so long dated bonds are much more volatile than short dated bonds when there's a change in interest rates. When interest rates go up, bond valuations tend to go down because the market rate has increased. So if I can get 5% elsewhere and my bond's only paying 3%, then my bond is worth less money if interest rates go up because now I can get more money elsewhere. So automatically my bond goes down in value every time interest rates go up because my bond's paying a fixed amount of interest. The payment on my bond's interest is not going to go up even though interest rates are going to go up on other bonds. So it just, interest rates increasing decreases bond valuations. Uh, and so bonds don't go up in value when interest rates go up, they go down. Uh, What happens when inflation goes up? Well, when inflation goes up, your money's going to be worth less in the future than it is today. We're going to have 10% inflation, and I have $100,000 today. That means I'm going to have 90,000. My 100,000 is going to be worth 90,000 in a year. I'm going to lose 10,000 in purchasing power. And so, if that's the case, if I'm going to give somebody cash and all I'm going to get back is a payment to give me, a fixed amount of money back in a year, I'm going to want to charge more rent for my money. So I'm going to want to charge more interest on my bonds if there's more inflation. And I'm going to want to charge less interest on my bond investments. When I invest in something, I'm going to expect less interest when there's lower inflation. Because at the end of the day, I need a higher interest payment if there's higher inflation to offset the inflation. So I'm going to charge more rent for my money if it's going to lose more value over time.